This lesson is on graphing inequalities in two variables. We can start by remembering how we graphed inequalities for one variable. If we had x is less than a, for example, we'd have our number line, we'd have a here, and x is less than a, would mean everything before a, in an open circle. The open circle is because it doesn't say less than or equal to, it just says less than. However, if it was less than or equal to, then it would be a closed circle, and I could fill it in. So if that's a brief review of one dimension, or one variable, let's look at two variables. We usually use y for the second variable, so for the sake of simplicity, let's just use y and not x. If y is less than 2, you could do a number line. You could have 2, and y would be less than 2. What if we turn this number line on its side, or vertically, however you want to think of it? It would look like this. And at 2, y is less than 2, so it's going to be below 2. So that's what y is less than 2 kind of looks like, but that's not exactly right. What we'll do is we'll actually draw an entire graph and label our axes, y and x. And let's say here's where 2 is. If y is less than 2, that means it's going to be any of the stuff down below it. If I had a nice pencil, I would shade this in, uniform, and everything like that, make it look nice. But it's all shaded in, except when we're at 2. Before, for one variable, if we had y was less than 2, we would use this open circle. With two variables, instead of using an open circle, you use a dashed line. So here, I do a dashed line. And what I shade in goes up to that dashed line. So if it's a dashed line for y is less than 2, can you guess what it's going to be if y was less than or equal to 2? Well, it's just a solid line. So you'd have a solid line, and then you'd shade in everything that's below it. Now that was a really simple example. What you're probably going to see more of is something along the lines of a linear equation. If we look at y equals mx plus b, here I can graph this. If I have b here, let's say, this is x, this is y. And let's say m, we go up some amount and over some amount. This is what that line looks like. But what if that's not what the problem is asking for? What if, when I work out the problem, I get something like y is greater than or equal to mx plus b? Well, then I shade in everything that's above, and because it's greater than or equal to, remember, equal to, for one variable, we'd have a closed circle. For two variables, we have a solid line. So that's that. And we'd shade in what's above. That's not usually what it's going to look like when it's given to you, though. When you're given a problem, you're probably going to get something that looks like x plus 2y could be less than 4, for example. In which case, you just subtract x from both sides, and you'll get that 2y is less than 4 minus x. And then you could divide both sides by 2. And because 2 is positive, we don't have to do anything crazy like flip the sign or something like that. So y is less than 2 minus half of x. And this can be graphed, again. The y-intercept is 2, and the slope is negative 1/2, which means I go down 1 for negative 1, and over 2 for the 2 on the bottom. So that's what that line looks like. But wait, this is y is less than 2 minus half of x. So to begin with, I'm going to have a dashed line, because it doesn't say anything like less than or equal to. I'm going to have a dashed line, and then because it's less than, it's anything that's below that gets shaded in. In summary, when you want to solve an inequality in two variables and graph it, you really just treat it as if it was a regular equality. The only difference is if you divide by a negative or multiply by a negative, you have to switch a sign. But otherwise, it's basically the same as an equality. In fact, everything is the same even when you come to graphing it. If you end up having your solution mx plus b, and you have some inequality, you can just draw the line mx plus b, and then work the equality around that. Be sure to remember that for one variable, if we had less than, you'd have an open circle and shade what's before it. But if you had less than or equal to, you'd have a closed circle and shade what's before it. The same goes for greater than. But with two variables, if you have less than, you have a dashed line and you'd shade what's below it. And if you had less than or equal to, you'd have a solid line and shade what's below it. The same general idea goes for greater than and greater than or equal to. Check out the examples video to review more on the topic of graphing inequalities in two variables.